Hey everybody, Dr. Nelson here. This is a video on something called difference of squares. So the notes you have, the first two pages you're going to follow along with me, and then you have a chance to try some problems on your own, and then at the end you can see how you did. Alright, so what exactly do we mean by difference of squares? Alright, well this is a special type of factoring, and take a look at this first problem over here. We have the binomial b plus c times the binomial b minus c. So if you notice, the first binomial, we're adding two different terms of b plus c, and that's what this is right here. So the sum of two terms, and we're multiplying it by their differences. So the b minus c is their differences. So let's actually use FOIL to multiply these out. So you should know by now that FOIL stands for first, outside, inside, and last. So when I multiply the first, we get b times b, which is b squared. When I multiply the last, we get c times negative c, which is negative c squared. When I multiply now the outside terms, we're going to get negative bc. And when I multiply the inside terms, we're going to get just a positive bc. Now, if I wanted to simplify this, look at these two middle terms. What's going to happen to those terms? Well, they're opposites, right? So because they're opposites, they're going to cancel out. So we're going to end up now with just b squared minus c squared. So that's what this is over here. So we have the square of the first term. So the first term was a b, so we get b squared. And we have the square of the second term. The second term was a c, and we end up with a c squared. And it's the difference of the two. So let's try another one. So here we have x plus 2 times x minus 2. So we're going to end up now with, again, let's use FOIL. So the first term is going to be x times x, which is x squared. The last is going to be 2 times negative 2, which is negative 4. The inside is going to be 2x. The outside is going to be negative 2x. And again, these middle terms are going to cancel out. So what's left over now is going to be x squared minus 4. Alright, but that's not what we're trying to get here. Okay, what we need to now do, I'm going to use a different color, okay, is imagine if I gave you this, and I wanted you to come up with this. So I want to factor x squared take away 4. Alright, now let me ask you a question. Where did this come from? Right, this right here is this, right, which came up from x times x, right, which came from multiplying the x times the x. Now, where did this come from? The negative 4. Okay, well that negative 4 came from here, which is the negative 4, which was the last terms, right, which is the 2 and the 2. Alright, so let's do some difference of squares examples. Let's say, for example, we have something like x squared minus 16. So, and I want to factor that. Now, this is a difference of square because the first term, x squared, is a square number, and so is the 16, because 4 times 4 is 16, and we're subtracting. Alright, so we want to factor this. And I know that the first term is going to be the square root of x squared, which is just x. And I know that the second term is going to be the square root of 16, which is 4. It's going to be 4 and a 4. And one of them is going to be the sum. So I'm going to put a plus here. And another one is going to be the difference. So I'm going to put a minus here. And there it is. That's the difference of squares when we factor it. So let's try another one. How about if I said x squared minus, let's go 25. Alright, so we know the first term is going to be an x and an x. We know the second terms are going to be a 5 and a 5. And 1 is going to be the sum, and 1 is going to be the difference. Now, another one that's a little more difficult would be something like, say, 4x squared minus 9. So it's going to be a 2x here, and a 2x here, and then a plus of 3, right, because the square root of 9 is 3, and then a minus 3. Alright, we turn the page. And let's try some of these, okay? So here we have x plus 8 times x minus 8. So if you can identify these as difference of squares, we know that this is just going to be an x squared minus 64. Well, here we have 4x plus 3 times 4x minus 3. Well, I know that 4x times 4x is going to be 16x squared, and 3 times 3 is 9, and it's going to be a difference of squares. Here we have x plus y times x minus y. Well, x times x is x squared, y times y is y squared, and it's going to be a difference of squares. Okay, again, because we have the sum of the two terms times the difference of the two terms. Here we have 2x times 2x, which is 4x squared, and 6 times 6, which is 36. And again, we're going to subtract. All right, now here we want to factor each binomial. Okay, so the first thing you have to say is this a difference of squares? And we actually already did this one, right? So look at the first term, x squared. Is that a square number? And the answer is yes, because x times x is x squared. Then we have 25, and we have to say, is 25 a square number? And the answer is yes, because 5 times 5 is 25. So we know we have a difference of squares here. So it's going to be an x and an x, and then a plus 5 and a minus 5. All right, the next one we have x to the 8th power take away 100. Well, I know for a fact that 100 is a square number because 10 times 10 is 100. But how about the x to the 8th? Well, this one is because x to the 4th times x to the 4th equals x to the 8th. So this is going to be now x to the 4th and x to the 4th and plus 10 and minus 10. All right, so this is a little introduction about difference of squares, okay? So what I want you to do is I want you to pause the video and do your best on the your turn problems now. And when you're done, hit play. You can see how you did. All right, good luck. Hey everybody, welcome back. Let's see how you did with the practice problems, okay? So in the first box, you had to circle each difference of squares expression. So x squared minus 100. Well, I know x squared is a square number because x times x is x squared, and 100 is a square number because 10 times 10 is 100. So this is absolutely a difference of squares. Here we also have a difference of squares because x squared, again, x times x, and 25 is 5 times 5. Now this one here, the number 8 is not a square number, right? So this is not a difference of squares. Y squared minus x squared. Well, y times y gives us y squared. X times x gives us x squared. This is absolutely another difference of squares. X cubed minus 4. Well, the 4 is, but the x cubed is not. So this is not a difference of squares. And this one here is a little bit tricky, but x to the 6th is a difference of squares. Is a square. Y to the 10th is a square. So this absolutely is a difference of squares, okay? And I don't know if you've noticed, but anytime you have an even power, we have a 6, we have a 10, we have a 2, and we have another 2, that's a sign that that term is going to be a square term. Here we had a 3 right here, and 3 is an odd number, so that's not going to be a square. All right, so now that you did that one, let's take a look at this. We had to factor each expression. Now these are all difference of squares. So hopefully you know by now that when you have difference of squares, you take the first term. So the square root of x squared is just an x and an x. You take the second one, 100. Well, the square root of 100 is 10 and 10. And then you make one the sum of the terms, and you make one the difference of the terms. All right, the next one, 4x squared minus 121. Well, 4x squared is going to be a 2x and a 2x. 121 is going to be an 11 and 11. And we're going to have a plus and a minus. All right, this one here is a little bit nicer. We got y squared minus 81. Well, the square root of y squared is y and y. And the square root of 81 is 9 and 9. Then we're going to have a plus and a minus. And this last expression, we have x squared minus y squared. Well, these are both square terms, and we're subtracting, so it's a difference of squares. So it's going to be an x and an x, and a plus a y and a minus a y. And there it is. All right, how'd you do?